Alrighty, we are underway. Let's put you up because that's what's the most important thing. We'll minimize that. We'll minimize this guy. Actually, I might put righto, we'll put that. Pop out chats. Yeah, let's leave that there. Alright, is the link not working today? Usually they jump on straight up. It is the right link? I think it is the right link today. Copy. Let's have a look, see. Paste. W4K, let's check it out. Let's check it out. Yep, that's it. Dude, morning. Oh no, is that morning? No, it's almost afternoon now. Crazy. Crazy. Sucks having maths late in the day, right? Mornings. Hey Zach. How you doing, mate? Hope you're going okay. Alrighty. Today we tackle probably, like, if you found it confusing thus far, the difficult part, right? Like I've said tons of times before, this is kind of like a brand new language, right? And so, like, once you've kind of got the basics, like up until this point, we've kind of got the basics down. Like, why are quiets? I don't know, mate. And it should be pretty sweet on my end, I'd say. Let's check it out. Yeah, no, my mic's all the way up here today. That should be fine. You'll have to check out your thing. Claustrophobic telephone. Hello. Hey, Phoenix. Hey, Jensen. Hey, guys. Good to see you. Yeah, so when it comes to multiplying and dividing terms, right, it's this weird aspect, right? It's like I said, the analogy this entire time has been like it's a brand new language, right? And it very much so is. Like when we learn a brand new language, we learn like basic things. Like if we're learning French, we learn bonjour, right? We learn bonjour, which equals hi, right? We say we start counting un, deux, trois, like as in 1, 2, 3. I think I spelled trois wrong. I don't know. Can't remember if I spelled it right. But we start learning these new words, right? Oh, of course. Is my thing going to stop working? Oh, no, there we go. No, we've come back to life. We start learning these new words, these new things. And this is kind of where we've been up to thus far, right? So we have learnt about, like, in our sequence of learning, we've kind of learnt about the notation slash the language of or actually it's more so the notation slash symbols, the notation. From there we kind of started to learn the sequence or the symbols. All right, and then from there we began learning. From there we started to kind of put things together. We learned like basic words, so basic terms, and combining those terms, so adding and subtracting stuff, things like that. Now, where we're up to at the point when it comes to multiplying and dividing terms, because this is multiplying and dividing terms, this is the kind of part of the language where we take what we've learnt here and we begin to form, like, how can I put this? we begin to use them in sentences. We begin to use them in different contexts. So when it comes to multiplying and dividing terms, which we're looking at today, whilst we have an understanding of what some of these words actually mean, okay, or in our sense here, what some of the notation and the sequencing out of basic terms mean, once we've got this, now we're kind of having to put some really tricky stuff together, all right? And that includes multiplying and dividing terms, okay? Which is what we're looking at today. Now, on your Google Classroom, let's have a look at the instructions for today. The instructions for today states, when it wants to load, click, let's go. It says, today, I would like you to watch the videos if you want to. Okay, you can do that in your own time. Write all the dot points down in your book. All the dot points? What? Did I say all the dot points? Surely not. Because the brackets number should be determined. No, we should, I would like you guys to write the first 5 down, I reckon. Yeah, the first 5. I'll change that. Edits. Let's change this. When it decides to load, this is what happens, right? Super. Write down the first 5. Let's change that. Morning, Charlie. Let's change this to the first 5, because these guys are the most important things, right? They really kind of, are you a sussy potato, sir? Dude, I have no idea. I'm totally not buying into what you're talking about. I know, obviously, I'm keen. I'm up onto. Yeah, never mind. Do you want to tell me who your name is, claustrophobic too, as well? That'd be great. Just so I know who you are. Now, first 5 dot points. So let's go through some of the questions, right? I don't know what you're talking. I'm not sure what you're talking about, Zach. Morning Star. Star, can you tell me who you are? That'd be great. But nice to see you. Morning. Now, here's the key part here, right? Now, by this stage, we kind of understand and we know our notation, but it's really important to follow up on this, right? AB is the same as A times B, right? A times B is AB. A divided by B is written like as a fraction, as we know it. And A times A, we use our index laws. So all this stuff here is nothing new, right? Nothing new. But what happens is, and what gets tricky is when we start having to get big, long, complex problems like some of these. All right, let's have a look. Let's just jump into some of the questions, right? You guys happy to do that? Does anyone have any questions before we start? Actually, what I'll actually do while you guys get comfy, Isabella, it's not letting me press on the videos. I can't help you there, mate. Sorry, I'm late. I didn't see the time. You're right, Isabel. That's fine. That's fine and dandy. So again, this is all about notation. This is all about notation. So 2 times x, right? 2 times x. I will change this to small and I'll zoom right in. 2 times x. We know this is just about language. We don't care. Yeah, if you want to watch the stream, you can do that. But remember, the videos are there to help support you when you're learning and stuff like that. That's fine. 2 times x. We know our notation is, quite simply, it's just 2x, right? Because we don't ignore the multiplication symbol. We know it's there, but we just want to write less stuff, right? So we have 2 times x. We move over here, of course, this is equal to 5p, right? Because, again, we don't want to write that. It's too much work for us. We're lazy. Over here, this guy here, this is 8ab. Again, we can see, boom, we don't have them, but we assume that they're there. I rub them out, not in the sense to say, oh, I'm getting rid of them. They're still there. We still understand that this is multiplication. We just don't write the symbols. Here's where things get a little bit funky, okay? Because thing is, I can go ahead and I can go, all right, I'll do this. 3 to a, but a little bit different, right? That doesn't seem right because This is like, imagine if I didn't even have, imagine if I didn't, I'll actually even do that. Imagine if I didn't even have this A here, right? It would just be 3 times 2. It would just be 3 times 2. So the nature is we can't forget our fundamentals. We can't forget our basics that are at play here. I have 3 times 2. I can actually solve that as 3 times 2, which I know to be 6, right? 6. I have got 6, and now I've got my A here. It's 6A, like that. Morning, Zali. Hey, mate. Alrighto. Over here, let's have a look here. Same deal again. I'm not writing 52AB, okay? Because again, I should set this as a favorite. 52AB, because if I just had 5 times 2 like that, I don't say 5 times 2 is 52. I say it's 10, right? So that's how I'm going to do this. Remember, do not forget your fundamentals. Your fundamentals haven't changed at all. They haven't changed at all, like so. So let's go ahead and solve this guy here. This is equal to, well, 5 times 2 is 10. And then a B, like so. The work, Zali, let me show you. The work is, this is it here today. Week 9, lesson 8, multiplying and dividing terms, like so. Like so. View material, like that. Righto, there it is there. Cool, cool, cool. September. Okay. All right. So hopefully that's making sense, and we can go through. You can go ahead and solve a bunch of all these things. They don't have to be in order, because remember this one here. Okay. This problem here, we had our commutative law, and I'll show you here. Remember, we looked at our commutative law. Commutative law was back here. Let's go back. Commutative law worked right back at the start. This was our laws of arithmetic, right? Our laws of arithmetic said, come on, load for me. Here it is here. Morning, Luca. Morning. Morning, Maddie. When it decides to eventually load here. All right, our commutative law says is that we can move and swap our stuff all around. So here, A times B is equal to B times A. So in this instance here, which I'll bring back up again, right? In this instance here, 2 times B times 5, right, is the same as, we can say, the same as 2 times 5 times B, right? And we can go ahead and solve this. So 2 times 5 is of course equal to 10, like so. And we multiply our B, like so. Our answer is just 10B, okay? Because of our commutative law. Our commutative law says we can put them all around. Oh, Maddie, you flatter me too much. Hey, morning, Caleb. Good to see you, mate. Morning, Seth. Same deal again. All right, 7 times 4, right? We can manipulate. We can imagine this in our head, right? 7 times 4, we know to be, what is it? 14, 28. 28, and then X and Z, like so. 28X, Z, like so. Righto? Cool. That's how we go ahead. I'm going to leave the rest of them for you to do in your own time and at your own pace there, like that. But that's really kind of about it, right? That's kind of about what the first 2 questions are about. If we move on to question 6 here, I'm going to pull this out and go 3A times 12. All right, I'm going to go down here with this one. Let's take this. Let's take 3, undo that. Let's make you bigger. Let's do 3A multiplied by 12. Now, here, right, straight up ahead, what I'm going to tell you is that you multiply this and this. My answer is going to be 36A, right? But before we go ahead, morning, Ariane, morning. Before we go ahead and we solve this, right? Before we go ahead and solve this, let's explain like how this came to be. Remember, this 3A here actually means 3 multiplied by A, right? And multiplied by 12. Doesn't this look awfully familiar to some of the questions that we answered, right? The point of algebra is to take simple or like complex problems and simplify them, right? Algebra, I've explained this before, but algebra kind of allows us to quickly and easily perform calculations without even thinking, right? Yeah. What am I using to draw? I'm using Notability to draw. I'll pull it up for you here towards the end, right? So when I do this, remember what I said before. I can multiply that and that. That gives me 36. And of course, I get 36a. So it's this idea here that I can apply to all of these questions. So rather than going ahead, can't I just use a calculator? Plus, when am I going to use? You actually use algebra like so much, Isabel. I'll tell you right at the end. So let's take something like this. So like you just multiply the numbers. This guy here, 15a. This guy here, well, there's no other number here, so this is just 8a, b, c, like so. We're simply learning a brand new language, right? We're simply learning a brand new language. It's just about taking something that's long and making it simpler, like so. All right. Any questions thus far? No, nothing so far. Cool. These guys here. Now, this one here, again, same deal as before, righto? This is our index laws. This is our indices. In actual fact, this first question here is given as a hint to you all the way back up into our summary, right? It says a times a is written as a squared, like so. No, she's not making things difficult. Right, hang on. I'd appreciate you not hijacking the chat, right? That would be awesome. So, given that, right, this is, of course, is just w squared, right? Down here, underneath, right? 2, do I have any other number? No, righto, so my 2 is going to stay there, but I've got my 2k's, so this is 2k to the power of 2, or 2k squared, like so. Benny Edwards is here. Morning, mate. Down here, right? 6 times 2. We can multiply those two guys. 12x to the power of 2. Alright. We're going to calm this chat down, please. Please be on topic with the chat. I don't want you guys chatting about stuff like that, but if you're going to hijack the chat, I'll put you guys in timeout. Alright, here we go. Over here, of course, look at this. A times a is a squared. Down here underneath here again, right? 7. Is there any other number? No. It's equal to 7p to the power of 2. Here, we've got 2 whole numbers here. Alright? This guy here. Again, remember this problem here is the same as saying 3 multiplied by z multiplied by 5 multiplied by z, right? This, of course, here is going to be 15z to the power of 2, like so. Righto. Okie dokie. So that's how easy as it is, right? And more importantly too, guys, I'd like to reiterate, right? Like if I would really like to see your work. So Ella and Seth, And Luca, if you guys are going to sit here and spam my chat, if you guys are going to be out of control like that, I would actually like to see some work, right? So please hang tight, chill out, relax, no hijacking the chat, and do the work, please. I'm asking kindly, I'm asking respectfully. All right. Now, division. Here we go. Let's roll on to division, right? Division, remember, we're just representing as a fraction. We're not solving anything. We're not getting any answers or anything like that, right? Yeah, if there's two letters, you use the squared thing. Like, it's index notation, Zach. Like, remember when we did indices? We did indices and we combined indices. Like, if we had a whole bunch of values, I'll zoom out. Just give myself some space. If we had a whole bunch of values of the same, like if I had 2 times 2 times 2, like that, I said it was 2 to the power of 3, like that, right? So like it's the same deal with letters, right? If I have A multiplied by A multiplied by A, that's the same as A to the power of 3. It's just like index, it's just index notation. All right, Caleb, this trolling is enough. So yeah, so that's how it rolls there like that, okay? So that's what happens when we're multiplying this. I'll do one more where they're the same. So I, for example, what happens is we can do this multiplied by this, okay? And of course that gives us 36. And then we have r squared because it's r times r, right? R times r, like so. All right, as we move on, okay, as we move on. Now, these ones are really simple, right? These ones are really simple in the sense that, prob's not today, mate. We're going to jump straight on and have some lunch. I don't know about you, I'm starving today. I want you guys to kind of focus on some of this today. This can be pretty tricky. X over 5 today, all right, so that's that. Maybe later in the week. You're doing expanding brackets? Cool. I'll give these guys a few minutes to do that. I'll go to question. I'll do expanding brackets for you, Ash. Expanding brackets, question 5. Oh, cool. Equivalent expressions, right? Okay. In a quick snapshot, right? If we look at when we're multiplying stuff, right? Let's say if I multiply something like 3 by 2, right? We know of course the answer is 6, but remember, all right, hang on a sec. Sorry, Shauna. Hang on a sec. I'm just, yeah, division makes it a fraction, Zach. So this one here, but remember, I'm not interested in the answer, right? I can represent it something like this. Okay, I can represent it as a square, where this side here is 3 and this side here is 2. I can use an array, right? Now, I don't have to represent numbers like, I don't have to represent multiplication using letters. I can use using numbers. I can use letters, right? So if I have, let's say, 4a, that's equivalent to representing something like this: 4 multiplied by a, right? We can take it a step further, right? We can imagine that the side of my rectangle isn't just one length. Let's tell a story, and let's say that, all right, a person was measuring, they got to about here, they measured 3 to this point, and then from kind of this point onwards, they just kind of didn't really know how far it was. They did know that down here was 5. How can we represent this as an algebraic expression? Well, let's think about it, right? It's going to be this value here plus this value here, like so. But let's break our, there's so much blue. I'm actually gonna, let's break our rectangle up here, right? Well, let's have a look at our measurements. We can see that we can break it up into 2 squares, right? This one here, this is 5 multiplied by 3. And of course that gives me 15, like so. And this one over here, this one here is 5 multiplied by x, right? Which gives me 5x. So I can say that the entire area is, yeah, good Ash, yeah, perfect. It's 5 times 3. And I can say the entire area of this is 15 plus, because we're adding these two here, plus 5x, like so. Righto? So, given this is how I would express it. Righto? I would take the first length, which I know to be, which is this guy here, which is of course 5. And then I would take this length here, which I know to be 3 plus x, like though. Okay? So that's kind of the synopsis of what it's like. Yeah, it's like doing equations but for shapes. Essentially, that's kind of what's happening up here, right? For the following rectangles, write 2 equivalent expressions for the answer, right? So let's have a look, see here. So we can do it in terms of just the length of each side, right? So this side here is 12. This side here is x plus 4, or 4 plus x, right? So we can say on my first expression, it's going to be, we can say it's 12. We can say it's 12, open bracket, because there's a little 12 there, right? 12x plus 4, like so. And we can say that it's equivalent to, 12x plus, can't do math, 48. Like that there. Okay. So that's how we kind of go ahead and we solve that. The word that we give to moving from this one to this one here, we actually have this a name, give this a name, we call it the distributive law. Distributive law. Because, and we learn about this in that second lesson there, right? Because what happens is it's 12 multiplied by x, and then 12 multiplied by positive 4, like so. So if we think about it, this is 12 multiplied by x, let's do that, plus 12 multiplied by 4, there, like that. Righto? Cool. Hopefully that kind of makes sense. That's kind of what this question here is asking us to do, like that. Good question, really good question. Seth, can you email me your work, please? That would be great. Caleb, I'm assuming you're at school, right? Cool. Alrighty. So, back to these guys here. So if we have a look at all of these questions here, I'll roll through some of our division stuff there. My email is, sorry Ben, can you be doing some math work, Ben, please? That would be great. My email, I'll put in the chat for you, Zali. Boom, there it is there. It's in the chat. Okie doke, let's check my emails. Elisha. Awesome, good job. Using it, cool, good job. All right. No worries. Ben, I would like to see your math work, please. That would be great. Email it to me. Cool. So back to division, right? So let's roll through this. Same deal as before. Our notation is b over 5, okay? Because remember, this division here acts as like a fraction. All right. I would like to let you know and be aware that this gets recorded as well too. So what I'm going to be looking for is that you guys are on task, and those, particularly after I've asked you, Ben, a couple of times to be on task, that I'm going to ask that you be aware that it's going to be recorded and that you be on task, right? So please stop. This guy down here, x divided by y, of course, because our division symbol actually means like a fraction, right? Now, here's where things get a little bit tricky. I'm going to identify where my division symbol is here, down here, right? So here's my division symbol. I'm going to use that as my bottom of my fraction. Everything over to the right of it here, like so, that's going to go underneath. And everything on the top here, over here, is going to go on the top, right? So, given this, on the top, I have got 2x plus y over 5. It's just about the notation. It's just about the notation. It's just about Zali, do you want me to I don't know. Caleb, I'm gonna let you know again that this chat is being recorded, right? Oh, cool. I'll check yours in a tick, Zali. I'm going to help Ash out here for a sec. I'm just to let you know, Caleb, that this conversation is being recorded. Everything here is being screen recorded. So your contributions are being recorded. And I would probably appreciate if you were on task, right? So for 5C, it's 3B. Yep, 3 open bracket 3BA 6. No, so you have to distribute that. So let's think of it like this, right? C is a little bit tricky. Let's break it down from a visual standpoint here, right? Let's have a look at this square first, right? This square first. Let me put that. This square first is, of course, 9, like so, because, of course, it is 3 multiplied by 3. That equals 9. Over here, in this square here, this is 3 multiplied by A. And, of course, that is 3A. This square down here, this one here is, let's do that. This one here is 3 multiplied by B. This, of course, is 3B. Down here, like so, this, of course, is A multiplied by B. So this here is just AB. Putting all of these guys here together, right? All these guys here together. We have 9 plus 3A plus 3B plus AB. So the long expression here, we could say, is 9 plus 3A plus 3B plus AB, like so, righto? The other way that we do that, right? The other way that we do that is we write it in terms of like an unsimplified expression. We can say it's this length along the top here, like so. So this length here is 3 plus A. And then this one here multiplied by this length here, which is 3 plus B. So let's do that. All right, this is 3 plus A, like so. Okay. Then we multiplied. Okay. We don't write the multiplication symbol. We just leave nothing there, but it implies that it's there. 3 plus B, like so. That's how it goes. Now, our distributive law, if we want to think of it in terms of our distributive law, okay, what we're doing is we've taken this 3 times 3 here, like so. This here is 3 times 3, like that. We then distribute this 3 over to here. This is my, over here, this is my 3 times B here, like that. And underneath here, we have A times 3, Okay, this is a times 3 here, like so. And then of course this guy here gets distributed over to here, like so. This one is a times b. So that is where we get that all put together. Where do you find the work, Shauna? It is week, not that week. Week 9, lesson 8. Let me show you. It's lagging a smidgen. All right, week 9, lesson 8. So there it is there. Week 9, lesson 8. There it is there. Good job, Ash. Good question. All right, we're gonna have a look at Zali's work. Let's have a look at Zali's work. Let's pull that up. Let's open that. I'm gonna pull Zali over. Alrighty, let's have a look. See. Morning, Mace. It's loading very slowly. Very slowly. Good job. Well done. Let's have a look what she's done. Had some trouble, but got it done. Great job. Well done. Excellent work. So let's have a look how she's gone, right? Let's have a look how she's gone. Let's have a look at C, because we didn't do questions. Oh, here we go. Let's go B. What did she get? So for B, she got 63D. Nailed that. Yes. Good job. 8C. Good job. 8E, sorry. Yeah, look at that. Good job. Well done. Well done. Good job, Zali. Top effort. So, guys, as you can see, right, you can literally take a photo of your work, drop it into like a Google Docs, like so, and then share it. So at the top right there, you can share, right? And you can share that to me and type my email into it, right? Nailed it. Good job, Zali. Good job. Now's the point, Zali, where you got to try and push yourself a little bit harder. Can't we just do it on Docs? Yeah, you can do it on Docs. This is what this is. She's put it through. This is Google Docs. You can, she's written it in a book, taken a photo, and uploaded it to Google Docs. Or you can just write your questions straight into Google Docs as well too. That's what she's done. Good job, Zali. Killing it. All right. Good job. Well done. Alright, let's have a look, see here. Yeah, he does, Maddie. Hey, Maddie, how are you going with the math work? Going okay? Right. I'm interested. Interesting. Who's the teacher? It's interesting though, right? I'm not sure that they're mean, right? But it's interesting. I find it really interesting. Well, one, thank you for popping on the stream today. But I also find it really interesting that your first priority was to like probably spam and engage in like really off-topic conversations. Like, I think the interesting thing here is that the work is all there, but they've all logged off now. Anyway. Oh, right, okay. She gets mad if we call her anything but sensei. Sensei, yeah, right. Okay. Ben, have you done the work, mate? Yeah, no worries. We're good. Ben, have you done, I'm just curious if you've done the work, Ben. See you, mate. Take it easy. Be good. Thanks for your questions today. Appreciate it. Appreciate it as always. No worries, Ariane. Hopefully that made sense today, right? It's a bit tricky. If you need more time on it, feel free to spend more time on it, okay? Take it easy, Mace. Be good, man. Well done. See you, Imogen. Bye-bye. Be good. Alright. Unless anyone else got anything else. It's been good. It's been real. I might make a few phone calls home, I reckon. Bit worrying level of engagement. Interesting. Thank you to all of those that asked some really good questions today. Appreciate that. I will see you guys. Ooh, when do I see you guys next? Tomorrow? The next day? Maybe the next day. I don't know. See you guys when I see you. See ya. Bye.